Alright guys, I'm going to go through, for those of you guys who would like it, through the practice test. So number one is asking you to, this is really asking us to just evaluate functions. You're evaluating function values. This was in your piecewise functions worksheet and on your first quiz. All I'm doing is I'm plugging x values into my graph. So let's see, when f of negative 2, when x equals negative 2, negative 2, is that less than negative 2 or greater than or equal to negative 2? It fits this category, so I'm going to plug it into here. Negative 2 squared plus 1, which is 4 plus 1, which equals 5. F of 0, 0 is greater than or equal to negative 2, so it still uses the bottom piece. So 0 squared plus 1 is 0 plus 1, which is 1. F of negative 4 equals, well, negative 4 is less than negative 2. It's more negative than negative 2, so we're going to use the top piece, which is negative 8 plus 1, which is negative 7. All right? Go ahead and check. All right, good. Is it continuous? Well, if I were to graph this, I would have, one way to do this is by graphing. And I know that the transition point is at negative 2. When x is less than negative 2, we have a line that actually at negative 2, if I plug in, this is negative 2, this is negative 1. If I plug in negative 2 times 2 is negative 4 plus 1 is negative 3. So I'm going to be at negative 3 with an open circle. So the y-intercept would have been 1. I would have gone down 2 over 1, down 2 over 1, down 2 over 1. So basically it's a line here. This is going to be a quadratic that went up 1 this way. If I were to plug in negative 2, we know that we go all the way up to 5. 1, 2, 3, 4, 5. So here is my other piece. So clearly there's a jump here. And so, no, f of x is not continuous. Okay, the way the explanation here, it says it's not continuous because f of negative 2 equals negative 3 in the first equation, but f of negative 2 equals 5 in the second equation. This creates a jump in the graph. Technically, you cannot say, so since negative 2, when x equals negative 2, it actually uses this, and so this is the real solution, the actual solution, or actual value. But this is the value if we were to plug it into the top equation, although this is where the open, basically this is where the open circle is, this is where the closed circle is, and so the open circle and closed circle actually have to match in order for it to be continuous, but here there's a closed circle and an open circle, there is no match, okay? So there's a jump, so it's not continuous. For example, if I plug in negative 2 to this top one and I actually got 5, that means the graph was like this, then even though there's an open circle and a closed circle that the same y value, then it would be continuous, but that's not the case here, that's why it's not continuous, okay? So if you're confused, like if you don't know what to do, first thing is you could graph it. And you could just tell if there's a jump or not, or a break in the graph. If you have to pick up your pencil, it's not continuous. If you don't want to do that, you could basically go ahead and go to the transition point, and even though there's an open circle here, plug in this value into this top equation, plug in this value into the bottom equation, and see if you get the same output. If you get the same output, that means the graph would be continuous. If that was confusing, just replay that again and see if that makes sense to you. All right? Alright, so the next one I ask you to graph. Again, x equals 2. I'm going to label my axes, x, y, and this is 1 and 2. I'm scaling it just normally. Each box equals 1. So this is my transition point. When x is less than 2 or equal to, that means to the left of my transition point, I have a parabola. I know a lot of you guys are really, really excited about making tables, but I don't really use that if I know if this is a simple equation. I don't really need to make a table because I already know this is a quadratic, a parabola that's shifted down by 2. So parabola normally starts here. If I shift it down by 2, I'm going to start here. And how do I get my other points? Yeah, you can make a table to plug in, but I already know on a parabola, I go over 1 and up 1, back 1 and up 1. I know on a parabola, if I go over 2, since 2 squared is 4, I have to go up 4. 1, 2, 3, 4. Back 2, up 4. 1, 2, 3, 4. Since negative 2 is squared is 4 as well. Now here, since it's x is less than or equal to 2, because of that line, I'm going to fill this hole. Because when we can actually equal 2 in this piece. When we equal 2, we get 4, so we can fill that hole. Of course, when I go over 3, I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so, you know, even though it's a sketch, you need to have at least a few key points. Okay? Now the other piece is a square root function. And I know how to deal with square root functions because I studied my parent graph toolkit when my teacher told me to in September. Okay? I know a quadratic normally starts at 0, 0, but this is a horizontal shift 2 to the right. So I'm going to start here. And hey, look, anyway, that's good because this graph only applies when x is greater than or equal to, or greater than 2. That means on this line, this graph cannot actually have any points. The most thing it could have is an open circle. And so it does. And I also know about a square root function is that if I go over 1, the square root of 1 is 1, so I can go up 1. When I go over 4, 1, 2, 3, 4, the square root of 4 is 2, so I can go up 2. Why do I not want to go over to 2 or 3? I mean, I can, but the square root of 2, I mean, you know, from here, it's going to be an irrational number. So square root of 2 is like 1.7, and so I guess I could find 1.7, but I don't really need to worry about that if I know I know from my parent graph that the shape is going to be like this. Now you might be saying, how do I know that? I'm going over 1 from here, because I know if I was over here, if I go over 1, it would be 1. If I go over 4 from here, I would go 2, and I'm just shifting everything over 2. If that doesn't suit you, you can this actually is a x value of 3, and I could plug in 3, and 3 minus 2, the square root is the square root of 1, which is 1, and so I know I go up 1. But again, I don't have to do that if I just use my transformation. So here's my graph. Now, given h of x, so h of x is different from k of x. In fact, it's almost the same as k of x, but it's x plus 1 plugged into the argument of k of x, and then all the y values are subtracted by 2. So find the piecewise defined function. Okay, I'm just going to do this. So it's the same thing as k of x, except it's x squared minus 2. And then I'm going to subtract 2. This one, it's the square root of x minus 2, but now and then I have to subtract 2. Oh, not in the parentheses though. Subtract 2. Because I'm going to, okay. So what do I plug into that parentheses? I'm going to plug in x squared plus x plus 1. So x plus 1 is squared minus 2. And this is x plus 1 minus 2 square rooted. And then that whole quantity is subtracted by 2. As far as my transition points, my transition point used to be x is less than or equal to 2, and x is greater than 2. But now instead of x, I'm plugging in x plus 1. Okay, so if I were to simplify this, you know, we're going to leave it in vertex form, so you don't have to do x plus 1 squared. Just leave it as, x plus 1 times x plus 1, which is x squared plus 2x plus 1. Don't worry about that. Just leave it like this in this part. But minus 2 is minus 4. Okay, here we have x plus 1 minus 2. Okay, well, what's x plus 1? Well, positive 1 minus 2 is negative 1, so I have square root of x minus 1. The whole thing is subtracted by 2, but I cannot, that's not under the square root, because this minus 2 was after the whole k function, so after this whole piece, we're going to subtract 2, so that's going to stay out there. For my transition points, if I subtract 1 on both sides so I could get x by itself, I'm going to have x is less than or equal to 1, and over here x is greater than 1. Which makes sense, since I shifted the whole function to the left, the graph to the left by 1, instead of my transition point being at 2, it's going to be by shifted over left to 1. It's going to be here. So this is my new function. Alright? Alright. Oh, I gave the same question again, I guess. So given the graph of f of x at the right, find the period of the function f of 54. Since I know that, look, from here to here, 2 is the period, right? This graph repeats every 2 spaces. Because look, whoop, 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 the period is 2, right? It's important to know that the period is 2. Then f of 54, going over 54 spaces, it's like going over 2, and 2, and 2, and 2, and 2. 27 times, it's going to be 54. So it's really the same as 0 plus 54. And that extra 54 jumps doesn't really matter because it's periodic. 54 jumps is going to be the same as none. So really, it's the same as f of 54. That means when my x is 54, what is my y? Well, when my x is, when my x is 0. When my x is 0, where does the graph land? When my x is 0, where does the graph land? The graph lands right here, which is 1. To really drive this home, let's consider what is f of 55? Or f of, let's try f of 55. Well, 55 is the same thing as 1 plus 54. Now moving over 54 spaces, since 54 is a multiple of 2, because it's 2 times 27, it's like going over a period 27 times. This doesn't really have any effect. Sorry. So it's the same thing as f of 1. Well, what's f of 1? If I go, when my x is 1, when I go over 1, what is my function value? It's 0. Okay. What about this? What's my f of 10.5? Well, let's move this over here. F of 10.5. Well, 10.5 is the same thing as going over 10 spaces plus a 0.5. Well, does that 10 spaces really make a difference? No, because 2, 4, 6, 8, 10, that's a multiple of 2. That doesn't make a difference since the period is 2. So it's the same thing as f of 0.5. When my x is 0.5, that's half. Well, here's 1, so half is right, 0.5 is right here. Where does my graph land or fall? Right here, which is 3.5. So f of 0.5 is 3.5. Okay? Alright, factor completely. Well, we have 2 terms here. This term and this subtracted term. These 2 terms, 2 factors that these terms have in common is x minus 3. There's 3 powers of that here, 2 powers of that here. So the highest power is 2. Alright, so if we have x here, and this is x minus 3 cubed, this is 2 powers removed, so we have still 1 power left. Subtracted by, the 28 is still there, doesn't go anywhere. We took both of these powers of x minus 3 out, so what's left there is just a 1. Okay, so this stays here. Now what happens here? This can still be simplified. Okay, so first of all, this is going to be distributed. So x squared minus 3x minus 28. But look, this can be factored because 28, okay, what adds up to, multiplies to 28, but adds up to negative 3. Well, 7 times 4 is 28. Negative 7, positive 4 gives me negative 3. So really, this can be factored into x minus 3 squared. That's still there. But this is x minus 7 times x plus 4. And now we're fully, now we're fully factored. This was in many, many RMPs throughout the unit since last chapter. Alright, simplify the rational expression. You have 2 math notes, okay, in your packet. One is on adding rational expressions. Also, in your practice quizzes that I put on Schoology, there's a review section at the end, and there's a bunch of practice problems. So adding rational expressions. And there's also one on multiplying. So there's 2, and I would check those out if you are shaky on this. You guys learned this with Miss Williams last year. Multiplying rational expressions. Okay. So when we're adding, well, adding and subtracting is the same thing, right? Adding and subtracting rational expressions, you need to have a common denominator to add fractions. Think about it. 2/3 minus 7/4. Okay, you could only add or subtract these if they have the same denominator. You would want to make sure that these both have a denominator of the least common multiple, which is 12. So in other words, you multiply by 4 here on top and bottom and 3 here. Same thing. But now look. So the least common multiple is 24x. So I'm going to multiply by 4x here and 4x here. And I'm going to multiply by 7 here and 7 here. That way I'm going to get, ooh, this distributes 4 railroad tracks. This equals this. I'm making an equivalent statement. So this is 4x squared plus 8x over 28x minus 21x minus 7. Now these negatives are very important, minus 28x. Since I have a common denominator here, now I could subtract. But look, this is 4x squared plus 8x. I'm going to have to distribute that negative. Okay, so that's negative 21x plus 7. When I combine like terms, these are like terms. 4x squared, 8 minus 21 is negative 13, I believe. 13x plus 7 over 2x. Okay. Hold on. Let me just make sure that my previous answers were correct. Good. Alright, good. So I would check, oops, this was supposed to be a 28. I would check to make sure that this is not factorable, because if it was, you might be able to factor. Actually, even if it was, there's nothing to cancel out here, so I guess you could stop there. But normally, I would make sure that to see if this can be factored or not. It doesn't seem like it is, so we'll leave it at that. Same thing here. We need a common denominator. Before, I would first factor to see if there's any common denominator that can be made, but this is not factorable. This is fully factored. This is fully factored. So look, I'm just going to have to multiply 2x over 2x on this side, and x plus 8 over x plus 8 on this side. That way, my denominator is going to be common. So let's see. If I factor this, the parentheses are really important. If I don't have the parentheses, I'm apt to think that I just can multiply the 2x by the 5x, but you really have to distribute it to both terms. So this is going to be 10x squared minus 12x over 2x squared plus 16x plus 9x plus 9 times 8 is 72, right? Over 2x squared plus 16x. Now I have a common denominator, so it's, and you guys know, some of you guys know, okay, well, I'll talk about that. 2x squared plus 16x. All over, what's going on here? 10x squared minus, I'm going to go ahead and skip a step here, minus 12x plus 9x. If I combine those like terms already, I'm going to get minus 3x plus 72. Okay, now I do want to keep things simplified. I want to check if I could factor this, but I'm going to tell you right now this cannot be factored. So I'm going to leave that. But guess what can be factored? Down here, notice that there's an x in both terms and there's an even number in both terms. So I could factor out a 2x. If I factor out a 2 here, then there's just 1 left, a invisible 1. Factor out an x here, there's 1 x left. Factor out a 2 from 16, I get 8. Factor out x from x, so here we are. Now x plus 8 is not a factor at this top, so nothing's going to reduce, so that's going to be my final answer. Now with this, you guys might have remembered or seen in your math notes that there's a trick. If you have a over b plus c over d, then you could go ahead and say ad plus bc over bd. But I do not want you guys to just use this as a rule, especially if you're going to be getting confused with cross multiplication, which is, this is not cross multiplication. And the only reason this works is because if I want a common denominator, I will have to multiply d and d on this side. and b on this side, on this fraction, and so you have AD, BC, and look, the common denominator is DB, or yeah, DB, which is the same thing as BD. So I would much rather you know just the process and not just memorize a trick. Okay? Trust me, it'll save you a lot in the long run. Because if you just memorize, oh, this is like a cross multiplying one, you're going to try to do that with multiplying, and that's going to get you in big trouble. Okay? All right. In fact, we can, let's just keep going in order. Okay, number 7, it says given the h is this and k is that, that was the equal sign here. Solve. Solve here means find x. Solve means x is a mystery number. We don't know what it is. You have to solve, do some investigating to find out what x is. Okay, and this actually combines a lot of concepts that were throughout your RMPs, whether it was factoring, solving for x, a lot of different things, and composition of functions. So that's the way this curriculum works. It builds, so you can't just expect to just tune out, skip a few RMPs here and there, and just get everything at the end. This is really a problem that combines a lot of different skills. So let's first talk about the composition here of functions. This is h of k of x, meaning that the k of x is inside the h. So I'm going to say h of k of x really equals h of, well, what's k of x? K of x, the inside part, is 3x minus 4. But what am I going to do? I'm going to do k on it. Hold on, I'm running out of batteries here. Hope you're still recording. So I'm going to do k on it. K on it. K on it. Okay. Oh no. Wake up. Wake up, my sleeping laptop beauty. Uh-oh. I don't know. Wake up! Wake up! Me too.
Did you have to start all over?
I don't know.
That's
I should say, study it on your own, guys.
you should.
Oh, wake up, wake up. Yeah.
Working.